Hey all, today we are going to talk about square roots and we are going to talk about simplifying them. So square roots are something that you can put into your calculator, and sometimes if we have these things called perfect squares, they'll give us answers that are not decimals, but otherwise we'll get answers that are decimals. And so what we want to do is we want to simplify them into their simplest radical form, so that we have something simpler than what we have, but also so it's not a decimal. It looks a little neater than a decimal. And sometimes we have to round a decimal, and so then it makes our answer not exact. So let's talk first about what a square root is. A square root is just a function. It does something to a number, much like adding or subtracting does, or squaring using an exponent. So we know that, let's say, for example, when we do 5 to the second power, or 5 squared, that means 5 times 5, which is 25. And so a square root is the opposite of doing a square. When we do a square root of, say, the number 25, what we're asking ourselves is, what did we multiply by itself to get this number underneath the square root symbol? And so when, in the case of 25, we know that we multiply 5 by itself to get 25, and so the square root of 25 is 5. These are opposite operations, much like adding and subtracting, and then multiplying and dividing. And so something to keep in mind are the perfect squares. You might know some of them. You don't necessarily have to memorize them, but it is helpful to know some of them. So some of the perfect squares are 1, because the square root of 1 is 1. And we have 4. The square root of 4 is 2. And 9. The square root of 9 is 3. And 16, the square root of 16 is 4. So 16 is a perfect square because when we square root it, we get an integer, a number that is not a decimal. 25, like we just talked about, is a perfect square. Square root of 25 is 5. And we could keep going. There's 36, 49, 64, 81, and 100. Those are the first 10. So 36, the square root is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10. So these are ones that if we actually did the square root on our calculator of these numbers, we'd get nice, neat answers. Well, if we went and did the square root of 192 in our calculator, we would not get such a nice answer. Let me do that. We'd get a decimal. And so what we want to do is simplify it. And then you can see we also have um, some variables in there. When we take a square root of a variable, it's a little different than taking a square root of a regular number. What we're trying to see is, can we divide this by 2? Um, let's stick with the numbers for now, and then we'll go back to the variables. So let's simplify the square root of 192. What I want to try to do is I want to find factors of 192, things that multiply to be 192. And I hope that one of the things that I multiply to be 192 is one of these perfect squares or some other perfect square. And so I know, because I've tried this one already, and sometimes this is a bit of, you know, trial and error. I know that I can divide 192 by 64, which is a perfect square. And 64 goes into 192 3 times. So these are two factors of 192. And so that means that the square root of 64 and the square root of 3 make the square root of 192. And so what's nice about this, that I found a perfect square, is I know, like I said over here before, the square root of 64 is 8. So instead of writing 64 with the square root symbol on top of it, I'm going to write it as 8. And then the square root of 3 um, is a decimal again, and so I can just leave that as square root of 3. So the square root of 192 simplifies to be 8 square root 3. And so what we want to do with the variable is we want to break that up into even numbered exponents. So I know that n to the fourth is n times n times n times n. And so I'm going to group them into twos. That's n to the 2. That's n to the 2. Let me actually rephrase that. I want to group these into groups so that I can divide the exponent by 2. What's really nice is I can divide 4 by 2 right now, and when I divide it by 2, I get 2. And so that's how we take the square root of a variable, and I'll definitely do another one or two here. The square root of n to the fourth is n to the second power. Because what we're asking ourselves when we square root is, what two things did I multiply to get n to the fourth? Well, to get n to the fourth, I did n squared times n squared, which we remember we add the exponents. And so to go in the opposite direction, we divide the exponents. It's different than when we have a real, just a regular number. And so I can finish this problem here by putting that into my answer and getting 8 n squared times the square root of 3. So I would deal with the numbers first and then the variables, kind of like we do when we simplify things. So in the second one, I want to deal with 128. I know also that 128 is 64 times 2. And so that means it's the square root of 64 times the square root of 2. I've just factored this, just the same as I could factor any number. Um, the square root of 128 is the same as the square root of 64 times the square root of 2. And I like that the square root of 64 is a factor because I know that that simplifies to just be 8. The square root of 2 is a decimal, and so I just leave it as square root of 2. When I look at m, if I want to square root m, m has an exponent of 1. And I can't divide 1 by 2 and get a nice neat number. And so what I'm going to end up doing is just leaving that m underneath the square root symbol with the 2, and I'm okay with that. Let me do a couple more. And sometimes this takes a little getting used to, like figuring out the perfect squares, like which perfect square do I think I can divide these things by. The more you practice, the more you do them, the more you'll get used to them and you'll notice. So I noticed that 16 goes into 32. So the square root of 32 is the same as the square root of 16 times the square root of 2. 16 times 2 is 32. So the square root of 16 times the square root of 2 is the square root of 32. And that's nice because the square root of 16 is 4. And so instead of writing square root 16, I'm going to write 4. Once I square root a number, the square root symbol's gone there. So the square root symbol right here is gone. And then I just have square root of 2 left over. And then I want to go handle my variable. So p has a even number, so I can divide 4 by 2. And that means the square root of p to the 4 is p to the 2. So I don't need the square root symbol anymore. So I'm going to go ahead down here and put that in between 4 and root 2. So 4 p squared times the square root of 2. Let me do one more. 18. 18's one that I'm used to. 18 I know is 9 times 2. So in this case, the square root of 18 is equal to the square root of 9 times the square root of 2. And we can go look here and find that the square root of 9 is 3. Now, these aren't all the perfect squares. You could keep going. These are just some of well, these are the first 10, the most common. And then square root of 2, again, is a decimal, so we'll leave it underneath the square root symbol. We're just simplifying. So if we can't take the square root and get a nice number, then we just leave it. And now let's look at n squared. That 2 is divisible by 2. When we divide that 2 by 2, we get n to the first power. So the square root of n squared is n to the first. And again, a square root is asking, hey, what number or what thing did I multiply by itself to get this? N to the first times n to the first. We add those exponents, we get n squared. So that's how we decide the square root of n squared is equal to n to the first. If you do have trouble with this, make sure you ask me for help before you get too far. Maybe we can clear this up together. So I will take my n to the first, put it over here in between. I don't have to write the 1. If you do, it's not wrong. And there I have my simplified uh, uh, square root. What I would recommend when you're doing practice is to maybe practice just simplifying the number portion and then go back and start simplifying the letter portion. So do one part of it at a time, and then you can put them together at the end. And in fact, when I ask you these questions here, I'm going to ask you to do that. I'll ask you to find what is the simplest radical form of the number, and then what is the simplest radical form of the variable. So you can see if you're getting maybe one wrong more frequently than the other. That's the part you need to practice. So as always, before you start these, if you had any questions on the problems I did or anything about this lesson, please make sure you ask first. Don't get too far before you get unstuck. Make sure you do these problems. And of course, make sure you do some more practice because that's what gets you better at these. It gets you better at recognizing the perfect squares and with simplifying these radicals. Good luck.